Okay, introduction states that the band Two Turtles and a Sloth took a 2-week break in the middle of their tour, which was just enough time for the groupies to mow enough lawns to keep them rolling in the money for the rest of the concerts. However, at the end of the second week, they started getting stir crazy and looking for something to do. They were deciding between two options: Wild Water West in Sioux Falls, which required $30 per person for tickets and $220 for gas, hotel, food, or renting a pontoon and setting sail on the river for a few days, which required $60 per person for the rental cost and $120 for gas and food. The question is, how many people would need to go for both options to cost the same amount? Okay, well, looking at this, I'm going to put Wild Water West up here. I know it's $30 for tickets. I know it's $240, and I'm just going to put for gas. Okay. Pontoon is $60 for tickets and $120 for gas and food. And again, we're trying to figure out, or tickets and rental, $60 for rental. Maybe I'll put that over here. Okay, per person. So let's look at this. The pontoon costs $30 more to rent. Okay, so the pontoon is $30 more per person. But looking at Wild Water West, it looks like it's $120 more for gas. So we have $120 more, not per person, but just more for gas. Okay, so we've got Wild Water West with $120 more. This is $30 more per person. So we're trying to figure out when they're going to cost the same. Well, if we have 4 people that go on the pontoon, that's going to even out that $120. So looking at this way right here, we're going to say 4 people. Okay, does that make sense? Yes, because Wild Water West, if we had 4 people that got tickets, that would be $120 plus the $240 for gas. It's going to cost them $360. Okay, if we had 4 people over here for our pontoon rental, that's $240 plus $120 for gas. It works out $360. Okay, so one way to think of that, just kind of evening out what does one have that the other doesn't have. Okay, another way to look at this is as an equation. I created some little teeter-totters here, putting that equal sign in the middle, knowing that each side has to balance out. So I'm going to write an equation for this. I know Wild Water West is $30 per person. So that's my 30p. Plus it's going to cost $240 for everything else there. Okay, I want to figure out when that price is going to equal the $60 per person plus that $120 for gas. Okay, looking at this, again, we realize that both sides at least have $30 per person. So we see that the pontoon actually costs $30 more per person. So I'm going to focus out. I have already seen that. So they each have that 30. He has 30p left over. Okay, these both each have 120. The 240 has 120 left over. So I got rid of what they had in common and I wrote what was left over. Well, now look, now I have an actual pretty simple equation. I have 30 times p, and I want to see when that equals 120. Well, we realized that 4 people was going to make up that $120 for the extra gas here. So really what we did was we divided that out. 30 or 120 divided by 3, how many people is it going to take? 4. Because if 4 people go on each one of these, it's going to cost them that $360. This is a little bit different than the equations that we were solving earlier because we do have a variable on each side. So what we have to do first is combine them. Technically what I did here was I subtracted 30 from each side because I realized they had that in common. So I could get rid of the 30 on this side and just focus on what was left over here. So I'm going to skip this type of thinking on this next problem, and I'm going to go just for solving that equation, looking at it as an algebraic equation. So question 2 states that they later find out that Wildwater West is closed, so they look into Wautiki and Rapid. Okay, so Wautiki is $40 per person, and it's going to cost $180 for the gas. Okay, now it's between that and the pontoon. Remember the pontoon was $60 rental, so $60 per person. And then it's going to cost $120 to gas it up for the couple days. Okay, so again, we're looking at the same thing. How many people would need to go for both of them to cost the same amount? So algebraically, I'm going to look at this, that it's 40 per person plus the 180. I want to find out when that price is going to cost the same as something that is $60 per person plus the 120. Okay, again, I'm going to focus on what do they have in common. They have $40 per person in common. We have $20 per person left over on this side. Okay, now I'm looking at gas prices. They both have $120 that they have to pay for gas. Okay, the Rapid trip is going to cost a little bit more, so it's going to cost them $60 more to go on their trip. So I have this chopped down into an easier type of question. We have 60 equals 20p. Okay, how many people will even out that extra gas money? 3 of them. So people equals 3. It would take 3 people for both of these to cost the same. Okay, still same concept. We're still solving equations. We're trying to figure out what that variable represents, but it's a little bit different because we have variables on each side. So we have one extra step, which is what this next section is going to be about. So please get out your notes and vocab for this section. Okay, objectives: to solve one variable linear equations with rational number coefficients, including equations whose solutions require expanding expressions using the distributive property and collecting like terms, aka a lot more than just 2 steps. So again, slow and steady, making sure that we get every single step in there correctly and that we're adding and subtracting correctly. And then the last one is to solve real-world problems involving linear equations, which we're pretty good at. All right, variables on each side. Again, to solve an equation that has variables on each side, we do use the addition or subtraction property of equality, which basically we went over in that introduction. Okay, figure out what they have in common and undo that. We're going to write equivalent equations with the variable terms on one side. So that equivalent equation, technically we did the same thing on each side. We took out what they had in common and we focused on what was left over. So now we're going to look at this a little bit differently. Example 1, again, we're trying to solve. What could we plug in for k to make this balance beam, or to make this teeter-totter the same on both sides? So it's always kind of hard as where to start. Usually we did the whole add or subtract. Now we have an extra step. Step number 1 now is to combine like terms. So looking at this, I have a 5k on one side, I have a 3k on the other side. And now that we're not looking at people, we have to look at how to get them together. My rule is if they're both positive, then you want to subtract smaller number. Okay, so I'm going to subtract 3k from both sides. And the reason being is I don't like dealing with negative numbers. So if I subtract 3k from both sides, then I keep everything positive. I still have a 2. I had 5k, I got rid of 3 of them, so now I have a positive 2k. I got rid of that k. So now this just equals a negative 6. So remember that that's adding the opposite, that's actually a negative 6. Okay, now we're down to a step that we can actually do, where now we're going to add or subtract. We have to get rid of this positive 2. Even though there's nothing out there, we know that it's positive, so I'm going to subtract 2 from each side. So I have 2k equals negative 6 minus 2 is a negative 8. This is multiplication, so to undo multiplication, I'm going to divide. K equals negative 4. And again, understanding, check your solution. If I plug a negative 4 in there, am I going to get the same answer? 2 plus a negative 20 is negative 18. Negative 12 minus 6 is a negative 18. So if I put a negative 4 in for k, my balance beam stays equal. Other ones, so this one, they were both positive. Definitely subtract the smaller number. If one's negative, then you want to add that to the other side. Add it to other side. Okay, last one. If both are negative, then you want to add technically the smaller number. And I think hopefully there's one as an example, and I will explain that in just a minute. Okay, go ahead and try guided practice 1A and 1B. We're going to go over 1C and 1D together, or unless you want to try them yourself and then start the video, but 1A and 1B on your own right now. Okay, looking at 1A, again, the very first step that we do before we start our adding and subtracting, multiplying and dividing is combine those terms. When we're trying to solve an equation, we have to get the one variable by itself. And since we have 2 right now, we need to combine them. So I did rewrite the problem because that was my bad habit. I should have rewrote it. Then I look at all of the different steps. They're both positive, so I want to subtract 3 from both sides, which means that I was left with a 2 on one side and a 4w on the other. And this is where kids want to look at that and say, oh, w equals 2. It doesn't. Look at what we're doing. We're trying to undo a 4 being multiplied by that. So I have to divide each side by 4. 2 divided by 4 is 1/2. So 1a should have been 1/2. Looking at 1b, we notice that there is a negative 7a and a positive 5a. So the rule is if one of them is negative, add that over to the other side. Keep everything as positive as possible. So I end up with 12a plus 2 equals just a 6. Now I go ahead and add or subtract. So if I subtract that 2 over, I get a 4. And again, be careful with this. Answer is not 3. I have to divide each side by 12. 4/12 is actually 1/3. So 2 fractions. Fractions are okay. You are going to get those as an answer. And speaking of fractions, look at this next problem. It looks pretty crazy. And this is one of my favorite things about algebra, is that I can change this. I don't like fractions. So I am going to multiply by something to get rid of all of those fractions. And what I'm going to do is I'm going to look at the denominators and multiply by the greatest common factor, which is 4. I'm sorry, the least common denominator, which is 4. So noticing that remembers to keep my teeter-totter balanced, I can do whatever I want with this equation as long as I do it to both sides. So I'm going to multiply each side by 4 to keep it balanced. So 4 times 1/2 basically is 2. So this ugly mess right here just becomes 2x. 4 times 1 is a positive 4. Looks a little bit better than that. Now I'm going to go to the other side. 1/4 times 4 is just 1x. So got rid of that fraction. But remember, this is that distributive property. 4 times a negative 6 is a negative 24. So much better to look at than that ugly mess up there. So again, look at that least common denominator, which is 4. That will get rid of both of those fractions, which it did. Now let's go ahead and go through the steps. Okay, I see that I have a variable on both sides. So they're both positive, which means that I'm going to subtract the smaller one. This is actually a 1x. So I'm going to subtract a 1x from both sides. So I had 2, got rid of 1, so I'm down to 1x plus 4 equals a negative 24. Last thing I have to do is subtract this 4 over. Okay, slow down on this. Negative 24 minus a 4 is a negative 28. So a cool little trick. As long as you do the same operation on both sides, you can manipulate this and change it to make it look a little bit prettier. So 1D. We haven't looked at decimals yet, but here they are. Again, decimals not as bad as fractions, but still they're kind of annoying. So what can we do to get rid of them? Well, let's go ahead and multiply by 10 on each side, which is going to shift that decimal on each one of those. Again, as long as I do the same operation on both sides, I should be totally fine. So this turns into 13c equals 33c plus 28. Do you have to do this? No. Decimals really aren't that bad, but I'm just showing you that you can manipulate problems as much as possible as long as you keep the teeter-totter balanced. Okay, so let's look at this. First step, I see that I have variables on both sides. They're both positive, so I'm going to get rid of the smaller number. I'm going to subtract a 13c from both sides. And this is where it gets kind of tricky. I mean, look at this. We have got 13c and we got rid of 13c. So there's nothing on this side. Nothing means 0. So I have a 0 on that side. Is that okay? Yes, 0 is a number. So I have 0 that equals 33 minus 13, which is 20c plus 28. Okay, still looking kind of weird, but we are down to just one variable. Now let's go ahead and add and subtract. I have a 28 I have to get rid of, so I'm going to subtract a 28. Again, 0 minus 28 looks kind of weird, but that is, I'm going to go over here. I'm running out of room. A negative 28 equals a 20c. Okay, what's my next step? Well, I have a 20 times the c. To get rid of that multiplication, I'm going to divide. Looks like a pretty crazy answer, but if you take negative 28 and divide it by 20, what do we end up getting? And here's another rule. Since this is written as a decimal, go ahead and throw that into your calculator, and you end up getting negative 1.4. So if the problem's a decimal, write the answer as a decimal. If the problem's a fraction, if this happened to come out of the fraction, we would have had to keep it. Okay? So many different concepts to work with here. Biggest thing, slow down and make sure that all of your multiplication, your addition, subtraction is correct. Okay, to add to the fun, this next example actually deals with those grouping symbols, those parentheses. So the directions state that if equations contain grouping symbols such as parentheses or brackets, use the distributive property first to remove the grouping symbols. So now we have one more step. We have to distribute first, then combine like terms, add or subtract, multiply or divide. So here comes my arrows to help me stay focused. I understand that I'm going to multiply a 6 through on this side. So 6 times 5m is a 30m. 6 times a negative 3 is a negative 18. Roadblock on this side, I see that I have a fraction. Before I get too excited about that and start multiplying things, I'm going to look at it real quick. 1/3 can actually multiply in nicely to 24 and 12, because that's basically saying 24 divided by 3, 12 divided by 3. So that's why I didn't get too crazy and start multiplying everything. I realized that I'm going to get nice whole numbers out of there. So 1/3 times 24 is actually 8m. 1/3 times 12 is a positive 4. So one extra step, but wasn't too bad. Now I'm on to step 2, combine like terms. So here's my directions again. They're both positive, so I want to subtract the smaller number, which is 8. 30 minus 8 is 22m, minus 18 equals a 4. And we should be getting pretty good at this next part. Again, we're down to add or subtract. So we're going to add an 18 to each side. 22m equals 22. Get rid of this 22 that's being multiplied, so I'm going to divide each side by 22. and I get m that equals 1. Again, we kind of have to visualize what we're doing here. What are we solving for? We have a balance. We have a scale in here, and we are trying to figure out what we can put into both of these m's in order to keep that teeter-totter balanced. 1 is the only number. If we stick some other number in there, we're going to have an unbalanced scale. So again, trying to visualize what it is that we are trying to solve for. Okay, go ahead and do these guided practice. Again, the steps. Distribute first, then combine like terms. Add or subtract, multiply or divide. Okay, here are the answers. Biggest thing here, making sure that we understand 3 times a negative 2s is a negative 6s. Since this term is negative, it's much better to add that 6s over to the other side. The question is it okay to subtract that 8s over here? Yes, that would be fine. You're just going to be dealing with some negatives. So the least amount of negatives, the better. Okay, looking at this next one. Biggest thing is once you get down to the bottom where you have 9n equals 1, slow down, realize what it is you're doing. You are dividing each side by 9 because we have to undo that multiplication. So answer is 1/9. Okay, again, that means that we would plug a 1/9 into each side of this to keep that balance being balanced. With that in mind, let's look at these next couple. It says that some equations may actually have no solution, which means that there's no number that we could plug in there that would keep it balanced. It's always going to be off by a certain amount. Okay, that is, there is no value of the variable that will result in a true equation that will keep it equal. Some equations are also true for all values of the variables, which means it doesn't matter what number it is. It could be 1, it could be negative 1/32. Whatever number we put in there, that balance beam is always going to be balanced. So we have to figure out when those happen. These are called identities. So we're going to find some special solutions out of this. So we're going to go ahead and go through the steps like normal. Step number 1, if we do have parentheses, we're going to have to get rid of them. So I'm going to multiply this 3 through. Again, I'm just going to rewrite everything else left to right. So I have 5x plus 5 still. But now I have 15x minus 12 minus 10. Notice I did not multiply that 3 by the negative 10 because that parenthesis stopped the distributing. Okay, combining like terms on this one, 10x. Combining like terms is a little bit different because look at this side of the equation, the right side of the equation. There's actually 2 terms. So before I do anything, I'm going to combine those. I have 15x, I have a negative 10x. Well, 15 minus 10 is actually 5x. So on this side, I have 5x minus 12. So sometimes combining like terms actually is 2 steps. If they're on the same side of the equation, I'm combining them. I'm doing exactly what it's told. Now I'm going to look at this, 5x plus 5. Well, this is kind of weird. I have a problem because I have a 5x on each side. So they both have a 5x in common, which means that if I got rid of them, if I subtracted 5x from each side, that gives me a 5, just the whole number 5, and the integer negative 12, 2 constants. Well, does that make sense? Does 5 equal negative 12? It doesn't. This is what's called a no solution. Okay, so we could say no solution. Sometimes you actually might see what's called the null set, which is a circle and a slash through it, which means, again, there is no number that we could put in for x that would keep this balanced because this piece is always going to be the same. On this side, we're always going to be adding 5. On this side, we're always going to be subtracting 12. So this side's always going to be bigger. Nothing that's going to happen. Okay, realize what I did was I got rid of the variable and I was just down to constants. So no solution. All right, moving on. Let's look at B. Have to go through my steps. I see distributing, so I'm going to distribute these through. So I have 6b. I have a negative 3, so 6b minus 3, and then a minus 7 equals the 6b minus 10. Okay, so looking at this side, I can actually combine these constants. Negative 3 minus 7 is a negative 10. 6b minus 10 equals 6b minus 10. Weird. Again, I have the same amount of variables, but look what happens. They have the same amount of variables. So if I got rid of them and said, well, they have those in common, I'm left with the negative 10, and I'm left with the negative 10. This is different because this is true. Negative 10 does equal negative 10, which means it doesn't matter what number we put into this equation, it's always going to be balanced. This is where we could put in a 1, a negative 1/32, a 1,000,002. Whatever we put in there, it's going to be the same. So this is called all real numbers. Okay, which just means whatever number we put in there will work. Fancy way of writing that is 2 lines. It's kind of like the paragraph sign, except we give it a tail and make it an R. Okay, so please realize the difference here. 5 is never going to equal negative 12, so no solution. Negative 10 is always going to equal negative 10, so any number will work. All right, let's try that for this one down here. Again, I see distributing, so I'm going to distribute this through. So I have 3x minus 12 equals a negative 12. Well, I distributed. Do I have to combine like terms? There's only one x. So next step, since I checked that one off, I have to get rid of this negative 12. So I'm going to add 12 to each side. So on the left, I have 3x. Over here, negative 12 plus 12 is actually 0. Okay, I put this example in here for a reason because some kids get to here and they automatically say that this is no solution because 3 doesn't equal 0. Well, look at this. I still have a variable. Up here, notice the variables disappeared. These are special solutions. This one, I do still have a variable, so I have to keep going. 3 times x. I have to get rid of that 3, so I'm going to divide each side by 3. Okay, so these cancel. I end up with x. Well, what is 0 divided by 3? 0. Okay, so not a no solution. If the variable stays, go through and actually find the answer. Okay, hoping you understand the difference between those 3 problems, go ahead and try guided practice 3. Okay, I wrote my answers in a fancy way just so we can start getting used to what these symbols mean. Remember, looking at this one, and actually you could have stopped once you get comfortable with this, you could have stopped with this step right here because we realize that each side is identical. We have a 12x on each side, we have a negative 5 on each side, which means that every number possible, all real numbers, will work in this first problem. 3b. Again, we could have stopped on this step right here, realizing that we have a 6y on both sides, but one side has a positive 20, one side has a negative 30, which means no matter what we put in there, one side's always going to be bigger, which is the null set, which means no solution. Again, I threw 3c in there just so we understand the difference between these. When we get down to 4x equals 0, we still have a variable in the problem. Don't give up on this. Keep going. Divide by 4 and realize that 0 will actually work in that problem. 0 is not a no solution. It is an actual number. Okay, this next part is really nice because, again, it kind of tells you all of those different steps. Again, simplify, use that distributive property, combine the like terms, okay, using those little tips and tricks with mine about what to subtract or what to add. Okay, then add or subtract, then multiply or divide. Okay, I like use the distributive property, but then I also like combine like terms. With that in mind, I do want to go back up here for a second because I just thought of something that students struggle with sometimes. This one right here, when we look at the 7x plus 5x right here, a lot of times I see students want to subtract 5x from the 7x because that's what they're so used to with combining like terms, getting rid of what they have in common. But that 7x and 5x are on the same side of the equal sign. So when we're combining those, we're doing exactly what it says. I always kind of see the equal sign as the wall. In order to get to the other side of the wall, we have to undo it. So I did exactly what these said to get the 12x. Now I have that wall in my way, so I have to undo it in order to get to the other side. So please stress that. Find out where that equal sign is, figure out if you can simplify on each side of that, and then start combining. Okay, with that in mind, let's go to this next part, and then I think we're done. Good. Okay, it says that we're supposed to find the value of x so the figures have the same area. All right, now we have to actually use some geometry terms and combine all of this. So looking at area, we want this area to equal the same as that one. Okay, so we want area to equal area. Area of this guy to equal the area of this guy. Well, we have to find the area of our square. Area equals length times height, right? So if we take this 10 times x, that's the area of our first one. Is it an actual number? No. Are you going to see a lot of actual numbers in algebra? A lot of times you're not to start with. So the area of this guy is 10x. Now we want to find the area of our second guy. Looking at this piece right here is x length. This one is 3. Together, they are x plus 3. Okay, so looking at area, we know it's length times width. I have a 6. I'm multiplying it by both the x and the 3. There's where my parenthesis comes into play. Okay, so I decided that it said we have to have the same area. So area 1, which is 10x, has to equal area 2, which is 6 times x plus 3. Okay, start small and then work your way up to what that means. Now, this is doable. We can go ahead and distribute the 6 through. Okay, so we distributed. Now we're going to combine like terms, realizing these terms are on opposite sides of that equal sign. So I'm going to have to combine by undoing. So I end up with 4x on this side equals 18. And then I have to divide by 4. Okay, 18 divided by 4 is 9 over 2. Or we could write that, it doesn't really say, as 4.5. Okay, these geometry problems sometimes really frustrate students because they want to see a number to start with. Well, a lot of times you're not going to see that. So remember your formulas, plug in what you know in order to figure out what you don't know. All right, one last guided practice. Go ahead and try it. Okay, before we begin on this one, I got kind of excited on that last one and didn't realize it's a standardized test, and they actually give us the answer. So the answer on that one is B as in Bob. All right, next one, more geometry. We're supposed to find the value of x so the figures have the same perimeter. So the very first thing that I did was I put the perimeter formula down. Twice the length plus twice the width. Then I also said, okay, I want one perimeter to equal the second. So then I looked at each one and I went to find the perimeter. Perimeter of our horizontal rectangle is twice the width, which is 2x, plus twice the length, which is 2 times 6, which is 12. And I did the same thing over here. So I have twice x, which is 2x, plus twice, and then I put a parenthesis of 2x plus 2. So I have to double that whole thing. Okay, so I found the perimeters. Now I'm on my next step that I have to put those two equal to each other. And that's what I did over here in the green. 2x plus 12 equals 2x plus 4x plus 4 because I distributed that through. Again, here we go. We have to realize that this 2x and this 4x are on the same side of the equal sign. So you have to combine those before you do anything. So I'm actually combining like terms in two different ways. Combining on one side and then subtracting 2x from each side. Going through the other steps, we find out that that is 2. Again, now instead of just having 2 steps, we moved up to 3 steps. And now we've actually moved up to 4. So do make sure that you are completing them in the correct order, understanding when we actually have no solutions, all real numbers, okay, or maybe just possibly the number 0. I think you're ready for this assignment.